Okay, today we are talking over long-run values, and hopefully by the end of the hour, I'm going to review for you what a long-run value is, and you're going to learn how to set them. So if I say I want the long run to come out to 100, you'll know how to change your equation to make it happen. Then we're going to learn how to use that to solve application like word problems. First, let's just do a simple one. Everybody take this, actually, back to here. Let's do this one at the bottom. I want you to put that one in your calculator and see what it heads to over the long run. So I want everybody to put it in their calculator and find U sub 50. I'll pause for a second while you do that. Okay, have I taught you enough yet so that you know that the long run, that 200 did you start with? It doesn't matter. You can start with 20, you can start with 200, you can start with 2,000. In the long run, it won't matter if it's headed towards infinity or zero or no matter what it's headed towards. Okay, so that does not matter. All right, I'm going to put it in as 200 just because that's what I told you to do. So now I'm going to go over and do my decay rate. Oh, okay, you're right. Thank you. That's not where you put that. That's a 0, and that's a 200 down here. Sorry about that. Okay, now I'm going to go up in here and put a 20% decay rate. 1 minus 0.2. Okay, good. And then I said plus 70, so I'm going to make that a 70. There we go. And then I'm going to go to the table, and yours should have looked for around U sub 50. Should look like this. Look at that. It's 350 over and over and over again. Okay. How could you have done that? Just with something simpler. 70 divided by the 0.2. Yep. That divided by that would have gotten you the right answer. But if you have a calculator on the test and you're allowed to use a calculator, wouldn't it be smart to just double check yourself and make sure? Okay. Now, next part is how do you set that long-term value to be different? Let's say I know that you know that if I change this to 80, of course the long-term value is going to be a little higher because I'm putting in 80 each week or each day or whatever time period I'm using. But how do you make sure that the answer will come out the way you want it? There is an easy way and a hard way. I'm going to start by explaining it the harder way just so that you understand it better, I think. Look at this chart again here. Do you get that this, it's 350 over and over and over and over again? So if I want the answer to come out to 350, and this is any random term, if I pick any random term, it should be 350. And the term right in front of it should be 350. So if I want this to have a starting value, I don't care what starting value. You can put anything you want there. This will not matter. You'll be given this. You'll be given a percentage that it's going to have to decay or grow. And this is the number you can play with right here. So you don't have to make it 70. So since it's not for sure going to be 70, I'm going to call it X. Then here's the last genius moment. If you want the long run value to come out to, let's say, 150. If I want it to come out to 150, what could I do in my equation? What do you know has to be 150? But what in this equation has to be 150? Where does that go? Nope. In this equation, if I put 150 here, will that make it turn out to have a long run value of 150? No, that thing doesn't matter. I told you that before. That's not where you put it. Where can you put the 150? On the outside for UN. And if that's 150, think about it. Isn't this supposed to stand for any random term, U sub n? Then what's the term right in front of it going to be? If it's in the long run, remember looking at this again? In the long run, don't they all come out the same? So that's also 150. That's how you set it up to guarantee yourself a long-run value of 150. You say 150 equals 150 times this part won't change unless we tell you it's a 30% decay rate or whatever. We'll tell you that part. And this part you'll have to set, and you won't know what it is, so you put an X. And now you just have to solve that little equation. Now, is it true that you could do it a faster way? Yes, but I need you to understand this way. And I know my colleagues were going to teach it this way, and since I'm recording the video, I need to do it this way. But this way will always work. Put that number and that number in as the long run value, the one you want it to be. Because if it's 150 here, if you're really in the long run, the one right in front of it was also 150. Okay, so now those two, if I'm going to solve this equation, you can't just divide by 150. It's a really common mistake. What you could do is you could say that's 0.8. 0.8 times 150 gives you what? 120. 150 equals 120 plus X. And if you can't solve that, I got to move you back a class. So you subtract 120, the answer is 30. Is there another way? Yes. You couldn't divide by 150 because you'd have 150 on the bottom of your X right there. See what I mean? That's what would mess it up. So you don't want to divide by 150 because of that. All right. So final answer, that came out to 30. I'm going to give you another example problem that's a lot like this. This one was I wanted my long run to be 150 and my decay rate was 20. All right, here's my next equation. Try to write an equation for this. Do this on the margin of that piece of paper I gave you. I really don't want you to have you take your iPads out right now. In fact, shut them, put them away if you were using them. I want you to focus on the paper today. I handed out a piece of paper for those listening at home. It's a little different than the worksheet that's posted. What? What are you doing? Right now, I asked you to just get out a piece of paper, and I'm going to tell you a situation. You're going to try to write me an equation. All right. You ready? You're not. Paper, come on. So, if you're going to write a situation for, or sorry, write an equation for this situation, do you get that if you have a pool, you have to put chemicals in it to keep the water clean? All right. Do you get that you don't just put the chemicals in once and then forget about it? You have to keep putting in chemicals. It's kind of like one of these problems where you have to add something every week or every month or every however often. If you were going to be perfect about it, you could add chemicals every single day. If you walked out to your pool, tested it, put in just the right amount of chemical, that'd be awesome, but it's a pain in the butt. People don't want to do that. So this is a situation like this. U0 equals, and that's how much you start with. So let's say that you needed to start by shocking your pool. If you bought a house and it had a pool and they hadn't been taking care of it, guess what? The water's not going to be very clean. It's going to be a little bit scary, in fact. Now, you could either drain the complete pool, which is actually going to cost you a lot of money to refill. It might cost you like $350 worth of just water. Okay, so because water's not free, your mom and dad pay for that, and when you're talking about filling up a pool, that's a lot of water. So you can clean the water, though, by putting in a whole bunch. So you start by putting in chlorine, and you put in a whole bunch of chlorine, let's say 400. 400, we're going to say grams. It wouldn't be gallons, that'd be a lot. 400 grams. A gram is like the weight of an aspirin. That's a good handy reference to have in your head. If you know, like how big is a gram? If you imagine just an aspirin sitting in your hand, that's a gram. Okay, so 400 grams of chlorine goes in to start. That's a starting value. Will that really matter in the long run? No, but it'll help blast a lot into your system so that the pool will get cleaned out. And what happens actually is the algae that was in the water and turning it kind of greenish or grayish or blackish will turn all gray, and so your water will be kind of cloudy. But then the filter system that's built into pools will filter the water out, and it'll be all clean. Okay, so basically you just have to add a bunch of chlorine. Now, you shouldn't just do this yourself because you need to know what the right levels are. You put in too much, and then somebody goes swimming in there, your hair is going to turn orange. We're not talking like red, like people with red hair. I'm talking about like orange, like it looks like you're a clown. So anyway, you need to be careful not to put in too much chlorine. All right, now the next part of the formula, UN equals UN minus 1. And why do we use this example of chlorine? Because chlorine decays. What decays it? Sunlight. And most pools are outside, and therefore the sunlight is slowly decaying them. I looked up the factor, it's around 30%. Sorry, that's an increasing, I mean decay, which is minus. Thank you. So it's going down 30%. So if we just left it alone, what would its long run value be right now? 0, because it's going to decay. It's going to go lower and lower and lower. Can you go to negative chlorine? No, that makes no sense. You could go to 0 chlorine, though. Okay, and how do I know that? Because I could put a plus 0, and then I could take 0 divided by 0.3, and that would tell me the long run. What's 0 divided by anything? 0. Okay. Now, what if I... Oh, okay, I'm going to pause for a second. Go. All right, we're back from the fire alarm now. We were talking about long run value and how you could set the long run value. So if I want, in the long run, my pool, I want it to have a level of 120 grams. Then I need to figure out what number to put here so that it'll end up having an end value of 120. So I don't know what to put there. So what you do is you put an X there if you don't know what to put there. This part is given. You can't change the decay rate of chlorine. So it has to be that. And this is always a 1 plus or a 1 minus. And then this part right here is the genius moment where you have to say, those are two terms in your sequence. They're a term and the term in front of it. If you get to the long run, what do you want those to be? Well, if you look at your calculator, in the long run on something like this one, what's my long run on this function? You can't read that? Those are that number over and over and over again is 350 right there. So I know, that's the one from the last one. But the point is, if you want your long run value to be 350, or in this case I said 120, then this number needs to be 120. And so does this number. Some people will never figure that out, but I think some of you will figure this out. Why do they both need to be 120? Because this is any term, U sub n is any term. This is the term right in front of it. Do you get how when you're way down the list and a thing keeps repeating, like in this case 350 over and over and over again, then any term is 350, and the term right in front of it is 350. That's why those need to be set to, in this case, 120. What do I have when I clean this up? I have 120 equals 120 times 1 minus 0.3. Could I say 0.7? Yes. Plus, I don't know what? X. Then you solve for X, gentlemen. Focus, focus. Now I have to solve that for X. What I want you to do right now is just focus on that. You're in higher algebra, for Pete's sakes. That is a simple algebra equation. Solve it. Use your calculator. That's 0.7. 0.7 times 120. What's 0.7 times 120? 84. 120 equals 84 plus X. And then subtract 84. What's X? Final answer? 36. So we have to add 36 grams of chlorine every whatever period of time this is, if it's based on weeks or months or years, however often we were doing it. Okay. So if we add 36 over and over and over again, it's going to maintain a level of 120. All right. I want you to make another one like that, except I'm going to change some stuff. This time, make a new equation. Put it in your calculator directly. Just go right to the calculator part. This time you're not starting with 400. This time you're starting with 1,000. You got a really big pool. So you need to put in 1,000 of grams, which is like 1,000 aspirin, which is basically about a kilo, like a kilogram. And in this case, not drugs. That's what you usually hear about when you hear about kilograms in this country. A kilo is 1,000 grams. You're going to put in a kilo of chlorine. And we want it to stabilize at, let's say that the new research says you really only need 82 grams to be your long run value. Remember, chlorine's got a constant, it's a decay rate of 30%, always is, won't change. We start with 1,000, and we want it to end at, what did I say? 82? All right. Now, you might want to do this on a piece of paper because you're going to have to figure out an x. Here's how I'd do it. U 0 equals 1,000 is what I started with, kilogram. Remember how that really didn't matter, though? Okay, next, un minus 1 times 1 minus 0.3. That always will stay the same unless we change. We'll tell you if we change it to a different problem for something else. And then this is I don't know. And then one more thing. If you did this right, you put right there, you put 82 and 82. Because on the long run, you want the number to be 82 and the number in front of it to be 82. Then I'm going to take this is 0.7. 0.7 times the 82. What's that? 50-something? 57.4. And then I'm going to subtract that from both sides. What's 82 minus 57.4? 24.6. So that must be my amount I should add every week or month or year or day or whatever you're going by. Yes, sir. And there is another way to do it, yes, and I don't want to guarantee you that'll always work. So you're taking the risk. So what I would do is if you have a neato way that you think works, do it. But then just check it with the calculator. You're going to have a calculator. And if you think that the answer of 24.6 works, then what do you really do? You put this into the calculator with a 24.6 right there. And if you were right, you'll be able to tell that the long run value on the calculator way down the table, it'll be saying like use 50, better be at 120. Otherwise you're doing it wrong. All right, I'm going to change this scenario just a little bit. I'm going to call it, you want to make an amount of money in your bank to stay consistent over time. Just like we wanted the chlorine level here to be 120, let's say that you start with $5,000 in your account. Right there, I just told you this. And you then have to figure out if you're going to spend, let's change it to 20%, 20% of your money every week. Then, what would you have to add each week so that you ended up with a long run value of $3,000? Start by writing it on paper, unless you're amazing at doing these in your head. 5,000 is what we started with. We wanted the long run value to come out to be, and this was a 20% decay, we wanted the long run to come out to be 3,000. All right, and this I don't know. So, you write an equation. And you say, I want the last term to be 3,000 and the term in front of it to be 3,000. And then 1 minus 0.2 is going to be 0.8. If you're doing it, oops. If you're going to do it a little faster, you might want to go with 0.8 there, plus x. And then 0.8 times 300 is 2,400. And if I subtract 2,400 from this and subtract 2,400 from that, this will cancel this. And I have x equals 1,600. So that means in real life, you're going to have to put in $1,600. Did I do that wrong? Okay, sorry. Whoopee. $600. You got to keep putting $600 in your account to maintain a balance of $3,000. Why do people want to maintain balances like that? Because in the real world, they ask you to maintain a minimum balance in the checking account. Otherwise, they're going to charge you like a monthly fee. And they would actually love it if you run below $3,000. Because then they get to charge you $12 a month every month, month after month after month. And it's a little annoying, but it's not a big enough charge that people like freak out. So they basically banks make tons of money on little fees like that. So if you keep a minimum balance, This is just an example of why you might want to keep a minimum balance in your checking account. And if it ever goes below 3,000, boop, they'll charge you that fee for the month. Actually, I think what they do is if the average balance falls below 3,000 in the month. So, but it's the same idea. All right. So I hope that you have learned how to find the long run value. I have a worksheet here that you can do for the rest of the time, and this is your only homework, is this one right here. One more thing, I would like you to go to your iPad, and I need to know how difficult last night's homework was for you, because I need to know how much to stress about, like stress that in my review tomorrow. Like maybe you think this is easy, but that was really hard. So last night's homework, on a scale of 1 to 5, 5 meaning you could like teach it to somebody else. You really totally get it, last night's homework. Or a 1, I am completely lost on things like last night. Okay? So all I ask you to do is, I was going to have you not billboard it to me, I was going to have you use the app. Just use the app, instant response thing. Go to your instant response thing, give me a number from 1 to 5. 5 meaning I totally get it. 1 meaning I'm totally lost. Somewhere in between is fine. Okay, I guess that's all I have for the video for today.